to our channel. This particular video that I'm going to make is on trigonometry. This is the first chapter of trigonometry that I've written, Trigonometrical Ratios. This particular chapter is of class 9 and I have thought of, at a stretch, I'll be completing the whole trigonometry that is of class 9 and 10 together. So let's get started with the first chapter of trigonometry, that is trigonometrical ratios, and let us have the initial idea of what is trigonometry. Okay, so as per I am saying the term that is trigonometry, and we are talking of the word, or rather we are using the word ratio. These ratios are actually calculated as per the right angle triangle. We don't take any other triangles but the right angle triangle. Whenever we talk about trigonometry, we consider the right angle triangle. Now, we have 2 to 3 types of triangle like angles which can be like formulated that we can check out once. Okay, the first one, let me draw it and then I'll show you. Now, see, I have drawn 3 different triangles. All are right angle triangles, right? But you can see I have marked the angle in different ways, right? So let us take this as the first figure, this as the second figure, this as the third figure, right? Now for this first figure, you can see this at angle B, it is right angled, okay? And this angle A is marked as theta. Now whichever angle we take, the ratios we take according to this particular angle. Okay, the ratios we take according to this particular acute angle. Now whenever we are taking this, so remember that wherever this acute angle is formed, that part is always taken as the base. The opposite side, okay, to it, or the perpendicular side to it is taken as a perpendicular, which you can also call it as, that is, which you call also as altitude. Okay, but here we are going to use the term perpendicular itself. So do not use any other term. I just told you to, so that you can remember. This is the perpendicular and the longer side is the hypotenuse. Similarly, for this also, see where the this right angle is at A, right? And which acute angle has been taken? At C. Now these angles, these acute angles which are taken for the ratios, okay, these can be marked in different ways. Theta, alpha, gamma, whatever names you can give. Okay, I can name it also as C. So that is up to you, or whatever type of questions is provided in the book. According to that you have to move. Next, as I said, this acute angle, wherever it will be with the right angle, that side will be considered as the base, and to the other side that will be the perpendicular. And as along, you can see the longer side will be the hypotenuse. Similarly to this, you can see this another triangle. Angle at B is right angle triangle, and at C it is, we have taken the theta, that is the angle. So the base obviously will be this, okay, and the perpendicular will be next to it, and the longer side is the hypotenuse. So please remember, whenever whichever triangle is given, you have to make sure that the acute angle and this right angle will be on the both the sides, which should be taken as base, and the other side will be taken as perpendicular. Okay, I hope I'm clear to you. I'll come with examples. I think the idea will be clear to you. Okay, I'm keeping this triangle for our later, these to denominate other ratios. Now I have written all the trigonometrical ratios here. It might look quite clumsy, but still I'll make you understand. You won't have any problem with this. Now firstly, I'm coming to the first trigonometrical ratio, that is sine theta. So sine theta has another name, that is sine. We know it as only sine. We don't write this particular spelling. Okay, so sine theta is equal to perpendicular by hypotenuse. That means AB by AC. We can write here AB by AC, right? So if we come to the next one, that is taking the reciprocal of sine theta, we get it as cosec theta. Reciprocal of sine theta gives us cosec theta. The other name of cosec is cosecant. We don't write that much, we just write it as cosec. Cosec of the angle. Okay, so that is if we are taking the reciprocal of this perpendicular by hypotenuse, that means 1 by divided by perpendicular by hypotenuse, we will be getting hypotenuse by perpendicular, right? Next, one more thing I would like to say, this particular angle, if you have any problem in writing theta, you can either take theta, phi, alpha, beta, gamma, A, B, C, whatever you want. Okay? You can name it in your own choice, according to your convenience. Okay? And yes, obviously according to the question that is provided to you, or rather in the book whatever is mentioned. In that particular way only. If in a question there is already it is given as suppose small a, you cannot change that to your own convenience. But yes, whenever you are trying to write or do sums by yourself, you can change it. Okay, now according to my way, I am just have taken theta. Next, I think this too is clear. Sine theta is perpendicular by hypotenuse, accordingly it is AB by AC, and cosec theta is the reciprocal of sine theta, that is hypotenuse by perpendicular. In the other way you can also write this, that means this is your AC by AB. Okay, next coming to cos theta. Now this is cosine. Okay, so we call it in short as cos. Cos theta is equal to base by hypotenuse. Now which is the base here? BC by AC. So we get here BC by AC, right? And the reciprocal of cos theta gives you sec theta. Sec theta, in other words, we call that as secant. Okay, we usually write sec only for that. So 1 by cos theta gives you sec theta. Now, what is the value of cos theta? As you know, is base by hypotenuse. So, reciprocal of it will give you hypotenuse by base, right? And according to this triangle, we will have AC by BC. Okay? Now, we are coming to the ratio tan theta. In other words, we call that as tangent. Now, tan theta is sin theta by cos theta. Sin theta value, you know, check it from here. Perpendicular by hypotenuse, right? And cos theta's value is base by hypotenuse. So if you divide these two values, you can see hypotenuse and hypotenuse will get cancelled and you will get perpendicular by base. So the value of tan theta comes out to be perpendicular by base. Just remember one thing, tan theta is equal to sin theta by cos theta, and then after that you can find it out. Okay? So that means perpendicular by base. Which is perpendicular by base? That is AB by BC. So you can write here AB by BC, right? Next, reciprocal of tan theta will give you cot theta. Cot theta is also known as cotangent. Cot is also known as cotangent. So 1 by tan theta means what? 1 by sine by cos, right? That means cos will go up in the numerator. You are getting cos theta by sin theta. So the value of cos theta is what? Base by hypotenuse divided by sin theta is perpendicular by hypotenuse. Okay. So in that case again, hypotenuse and hypotenuse is getting cancelled. You are getting base by perpendicular. This is the particular answer. Okay. Of the reciprocal of tan theta. That is cot theta. This is the particular ratios that we are going to deal with in this particular chapter of trigonometry. Okay, so base by perpendicular here you are getting as BC by AB. If you rewind this video, I think you can easily see these particular terms. And again, I'll repeat once more so that you don't have any problem. Sin theta, perpendicular by hypotenuse. Cosec theta is reciprocal of sin theta, that gives you hypotenuse by perpendicular. Next, cos theta gives you base by hypotenuse. Reciprocal of cos theta gives you sec theta, that is hypotenuse by base. Next, tan theta gives you sin theta by cos theta, gives you perpendicular by base. The reciprocal of tan theta gives you cot theta, which is cos theta by sin theta, gives you base by perpendicular. So these are the trigonometrical ratios. Next, what we will do, this is the only thing, main thing in this particular chapter. You just need to remember all this, nothing more than that. And yes, in particular, you need to see which angle it is concerned of. Okay? With which respect are we taking the ratios? We'll come to two different examples, I think it will be very clear to you. You won't have any problem. Now, look at the sum. Find all trigonometrical ratios for sine C, that is equal to 4 by 5. So sine means what? We have already seen that sine means perpendicular by hypotenuse. Perpendicular by hypotenuse, let me write the answer. Sine C is equal to 4 by 5, right? That means that is equal to perpendicular by hypotenuse. Now, which is a perpendicular? This AB, since here this is the base, this is the perpendicular, and this is the hypotenuse, right? I'm writing in short forms, but you please do not write in short forms, okay? So that means AB by AC, that is equal to AB by AC, right? Now it has been said we have to find the other ratios. Now, to our concern, this perpendicular value is 4 and the value of hypotenuse is 5, right? This is a triangle, that is a right angle triangle. Now you know that we can apply the Pythagoras theorem to find out the third side, right? Since Pythagoras theorem is applied for right angle triangles only. So accordingly to the Pythagoras theorem, by Pythagoras theorem, we know that hypotenuse square, that is hypotenuse square equal to perpendicular square plus base square. Here hypotenuse we are already having 5 square, that is equal to perpendicular square 4 square plus basis square. So basis square will be equal to 5 square minus 4 square, that is 25 minus 16, that is equal to 9. So base will be equal to, obviously as you can understand, is 3, right? So we can write the value here 3. We have got the value from Pythagoras theorem as 3. Next, we know the reciprocal of sine C is cosec C, right? So cosec C will be 1 by, that is perpendicular by hypotenuse, means we are going to get hypotenuse by perpendicular, right? So hypotenuse by perpendicular will give you what? 5 by 4. Got? Then cos C. Cos C is what? Base by hypotenuse. So base by hypotenuse will give you 3 by 5. Right? And please, when you are writing, for your case, since I am just dictating and writing the answer, for your case, suppose I am taking sec C now. Sec C. So it is going to come as, this is the reciprocal of 1 by cos, right? So in that case, we are going to get hypotenuse by base. That means we are going to write hypotenuse by base in this way. Or you can also write like this, that is AC by BC, that is 5 by 3. This way also you can write. Either you write this or you write hypotenuse by base. Any one of them you are going to write. It's better if you select this and write. That is, just write the sides and then write the value. Okay. Next, coming to tan C is equal to, we know perpendicular by base. Perpendicular is 4, that means 4 by 3, and the reciprocal of it, that is tan, is cot C, that is equal to, that means it will be the reverse of this, that is 3 by 4. Whenever you are writing, I said please write first, that is, suppose in case of cot C also it is base by perpendicular, that is base by perpendicular. So do write 3 by 4 like this. Okay, or you can also write, that is BC by AB, and then write the answer. Okay, first write the sides and then write the answer. So this is what is your, this finding out the trigonometrical ratios from a particular ratio given to you. A second example for you. Given cos A equal to 0.6, find sin A minus 1 by tan A. Now as you know, we already have this value of cos A. Now you might be wondering why 0.6, no decimal points are available here, so why 0.6? Now you can easily understand this 0.6 can be converted to the fractions also, just by taking out that point and dividing it by 10. So cos A gives you 6 by 10, right? Bring this to lower terms, you are going to have 2 3s and 2 5s. So you are having 3 by 5. Now for your convenience, just draw the right angle triangle. Now taking this as A, since we have the angle A, B and C, let this be the right angle triangle. So for A, cos A means base by hypotenuse. So which is base here? 3, and hypotenuse is 5. Okay. So by this Pythagoras theorem, we are going to get AC square is equal to AB square plus BC square. So we have here 5 square equal to 3 square plus BC square. So BC square is equal to 5 square minus 3 square. We are going to have 25 minus 9, that is 16. So BC is equal to 4. So what have we got for the value of BC as 4? Now sine A will be equal to, as you know, perpendicular by hypotenuse, that means 4 by 5, right? And tan will be, we know the formula obviously, that is perpendicular by base, that is 4 by 3, right? Or else you can simply take it from sine by cos also. But since we know the formula, we can write it directly. Perpendicular by base, that is 4 by 3. So here we need to find out the value of sine A minus 1 by tan A. Now what is sine A? Sine A is minus 1 by tan A. That is equal to sine A, we know it is 4 by 5 minus of 1 by 4 by 3. That means we are having 4 by 5 minus 3 by 4. That is equal to, take the LCM as 20. 5 4s are 4 4s are 16 minus 4 5s are 5 3s are 15. So you are getting 1 by 20. Okay, this is a particular answer. This is how we are going to do the sum. I hope I'm clear with this. Next sum, I've come with given, see, 5 cos A minus 12 sine A equal to 0. Find the value of sine A plus cos A by 2 cos A minus sine A. Now you can simply write down this particular equation that is given to you. 5 cos A minus 12 sine A is equal to 0. Now just write on the other side, 5 cos A equal to 12 sine A. Bring this 12 sine A on the other side of the 0. Now cos A by sine A, okay, equal to 12 by 5, right? Just by cross multiplying and writing or rearranging, okay. So here you can say cos A is equal to 12, sine A equal to 5. You can also take it in the other way, that is cos A equal to sine A, as you had from this particular step, okay, by 12 by 5. This also you can write. That means cos value is coming to 12, sine A's value is coming to 5. Now just simply put down the values. That means sine A's value is 5, so 5 plus 12 by 2 cos A means 2 into 12 minus 5. So 17 by 24 minus 5, you are getting 17 by 19. So this is your particular answer, right? Now coming with the fourth example, this is a particular figure given to you, okay. Now in this figure you can see that it is right angled at C and AD is a median. It is dividing the particular side BC into 2 equal halves, where you are getting the condition that BD is equal to DC, okay. Next, you have to find out the value of cot angle ABC by cot angle ADC. ABC is a bigger triangle, ADC is a smaller triangle, okay. Now cot means you already know it is base by perpendicular, okay. So remembering that, we will write the sides ratio. So cot of angle ABC, that is cot of angle B, will be having base by perpendicular, that is BC by AC, right, divided by cot of angle ADC, that means whole divided by ADC is how much? This particular triangle. That means it is DC by AC. DC by AC, that is base by perpendicular, right? So we can get from here BC by AC divide DC by AC. Now BC by AC into AC by DC. I hope you can see it. AC will get cancelled. Okay, so you are having the remaining as BC by DC. Now we know BC is BD plus DC by DC, right? Now this BD and DC both are equal, right? Since these two are equal, you can either write it as BD or you can write it as DC. Since here in the denominator DC is there, I am trying to write it in the form of DC. That means DC plus DC by DC, that is giving you 2DC by DC. So DC is getting cancelled, you are getting the value as 2. So cot of angle ABC by cot of angle ADC is giving you the value of 2. Right? I hope it is very clear. Okay? Because just the condition is here you can write since BD is equal to DC. This is only the condition for which this part is coming. Okay? Next. Now, next sum we are coming to find the value of sec square x minus tan square x. Okay? And here you can see a small figure has been given to you where the angle which we are taking is this. Okay? That is the x degree. So accordingly we have written the ratios. Okay? And the value of this hypotenuse and this particular side is given. Now, as I have told before that you are going to take which one as the base? The one which is having the right angle and the particular angle, acute angle, for which we are considering the ratios. So that means this particular side is the base and this particular side is the perpendicular. Accordingly, this is the hypotenuse. Now you just need to find out the value of this perpendicular. Using the Pythagoras Theorem, just find out. That means 2 square is equal to base square plus perpendicular square. That means 1 square plus perpendicular square. Or you can simply write this as y square. So y square is equal to 4 minus 1, that is 3. So y is equal to root 3. Okay? So value of y is coming to root 3. No need to worry that if root 3 is coming, are we going to change that into decimals? No. Please do keep the value in root 3 itself. Root 5, root 7, whatever is coming, keep that in that way. Okay? No need of converting anything to your decimal points. You need a log table for that again. Or you need to calculate it again. No need. Okay? So simply calculate, just write root 3. So for sec x, okay? Sec x means what? And tan x means what? Sec x means that is just the reciprocal of 1 by cos, that is the reciprocal of cos angle. Okay, that is cos x. So 1 cos x means what? It is base by hypotenuse. So here sec x will be hypotenuse by base. So hypotenuse here is what? 2 by 1. 2 by 1, right? And tan x is how much? Perpendicular by base. That means perpendicular here is root 3. Base is 1. So sec square x minus tan square x. You are getting what? Sec square x minus tan square x. Sec square x is 2 by 1. I am not writing 2 square minus tan square is what? Root 3 whole square. So I am getting 4 minus root 3 into root 3 will give you 3. That is equal to 1. So sec square x minus tan square x equal to 1. Okay, just what you need is to know the ratios. That's it. And then you can calculate. Okay, so this is how. And please remember, whenever this angle for which the ratio is going to take is been taken is on this upper side. Always remember, we are going to take the perpendicular and the particular angle, that particular side as the base. Okay, base will be on the side in which the acute angle and the perpendicular is there. And just at the adjacent side, we are going to have the perpendicular. Please do remember this particular one. Okay. and rest of it see which of the ratios or which angles ratio is given and do solve it. So this is what was about trigonometrical ratio. This is a very short chapter full of examples given. I think you can finish off nicely. So this was all about trigonometrical ratio. Please stay connected, because we are going to come up with other chapters of trigonometry also. So that is also very important for your syllabus. So if you have any problem, please do comment and ask me the doubts. And if you have liked this video, you have understood everything, please do like, comment, share to the others, and obviously do subscribe. And do press the bell icon also. You'll get the notification of the other chapters. Thank you. Have a good day.